Please have your notes open to section 3.4, Parallel and Perpendicular Lines. These notes are going to deal with three main statements, and their focus is on parallel and perpendicular lines. So we're going to start with the first statement. It says, if two lines are parallel to the same line, then they are blank to each other. Now, in order to know what they're talking about, let's go to our example here. We have three lines, A, B, and C. So that's saying it, what that first statement is saying is if A is parallel to B. So let's go ahead and mark A parallel to B. And we know B is parallel to C. So now I'm going to mark B parallel to C. I'm going to put 2 marks there. Then what do you think we know about A and C? Well, obviously, A and C have to be parallel to each other. And it sounds like the transitive property, and that's what it's using. Okay, so if we have two lines, and they're parallel to a same line, like A is parallel to B and B is parallel to C, then we can link A and C together because they would be parallel. Okay, the next statement says, in a plane, if two lines are perpendicular to the same line, then they are blank to each other. So let's go ahead and convert this given statement into an if-then statement using a specific example like the one we have over here to our right. So we need to have two lines perpendicular to the same line first. Alright, I have if A is perpendicular to D and B is perpendicular to D. So, and it's already marked with a perpendicular. So they are both 90-degree angles, which means the angle formed with A and D and the angle formed by lines B and D, those are congruent. So now we have corresponding angles congruent, and if your corresponding angles are congruent, then we know our lines are parallel, and that's what we need to fill in the blank here. Then A is parallel to B. Now we can go ahead and mark that. And parallel is what's going to go in our blank. So if we have two lines that are perpendicular to the same line, A and B are both perpendicular to D, then A and B must be parallel to each other. Okay, our last statement. In a plane, if a line is perpendicular to one of two parallel lines, then it is also blank to the other. So what do I need? I need, first of all, two parallel lines. And we're going to make A and B parallel. So if A is parallel to B, and now I need a line that's perpendicular. So I'm going to say A is perpendicular to D. So this is 90 degrees right there. Then what do you think the relationship is between line B and line D? They have to be perpendicular too. So B is perpendicular to D. That is actually called the perpendicular transversal theorem. Okay, we're going to use those three statements to answer the questions for number 1. A developer is planning a new housing complex. The map of the complex is shown below. Assume that all streets lie in a plane. If Washington and Lincoln streets are to be parallel, what must be true of angle 1 and angle 2? So here's angle 1, there's angle 2. And Washington is parallel to Lincoln. Well, here's your transversal right there. So if Washington and Lincoln are parallel, 1 and 2 would be corresponding angles. And what do you know about corresponding angles when your lines are parallel? The corresponding angles have to be congruent. So that's what we say. Angle 1 must be congruent to angle 2 by corresponding angles. Okay, question B. Which streets must be parallel if angle 3 is congruent to angle 4? Alright, so here's angle 3, here's angle 4. The one line they have in common is the street American Way. And the other streets that form 3 would be Washington with Jefferson. So what you have here is a picture. I'm just going to draw it off to the side. Here's 3, here's 4. In order for those angles to be congruent, lines have to be parallel. So which lines would those be? Washington and Jefferson. We'd say Washington and Jefferson need to be parallel. Now our justification is the reason those streets are parallel is because the alternate interior angles were congruent. Okay, so hopefully now I'm going to let you finish 1C, but hopefully this makes a little bit of sense. And if you have a lot of questions on it, you can hold your questions until Wednesday, and that's when I'm going to check your notes, so we'll go back over it then. Okay, so good luck.